Hello students, I am Akhilesh Kumar Srivastava from ABS Engineering College, Ghaziabad. In the series of the data structure lectures, we will discuss today about the hashing technique. In the earlier lecture, we have discussed about the linear and the binary search. We have seen that the linear search requires order of n time for the search operation. Similarly, the binary search requires order of log n time for the searching. There are certain cases wherein we require our data item to be searched quickly, instantly. For example, in case you are booking a cab from Ola or Uber or any such app wherein you give your start location, you give your destination location. Ola and Uber in the back end finds out a route corresponding to these two stations and tell you the fare, and then you go for the booking of the cab. In such a situation, you actually give the source in the form of any name, for example Nishadganj, Lucknow, and the destination also, for example Charbagh, Lucknow. So these two stations are the named stations, whereas in the background the computations are done with the help of longitude and the latitude, or you can say the coordinates. So very quickly we need the conversion of the named entities in the form of the coordinates. We cannot wait for a very long time for the searching of the names to be converted to the coordinates. Otherwise, the booking process will be very slow, and you can consider that how many such names will be there in the table where you are going to search these names. The table is going to contain lakhs of records, crores of records, because there are many places, and then in these lakhs and crores of the records you will be finding out one entity, one entry. You will require a lot of time for searching, even if you do it through the binary search, which requires log n time. So in such a situation, we need our data item to be searched in such a manner that you give the name, it gets the location, and it gives you the result. So for such a situation, hashing is going to be very useful data structure. So in the outline of today's lecture, we will discuss about what is direct address table, what is hashing, what are the various hash functions. We will also discuss about the collision in hashing, and then how can we resolve the collisions. We will discuss about the collision resolution mechanism. So before going to the direct address table, let us take one more example that will actually lead us closer to the hashing, which will actually make us understand about the hashing more. Let us say there is a compiler and you have written a program. It contains lot of things, for example the keywords. There are a lot of keywords you have written, and then there are a lot of identifiers you have written. आपने अपनी तरफ से बहुत सारे identifiers define किए हैं. Identifier means you have defined your own function, you have defined your own variables. तो इन सभी variables और इन सभी keywords को प्री प्रोसेसिंग और उसके बाद लेक्सिकल एनालिसिस फेज में इन सभी टोकन्स, इन सभी आइटम्स को टोकन्स के फॉर्म में एक टेबल में स्टोर कर दिया जाएगा. देयर विल बी अ टेबल दैट विल बी स्टोरिंग ऑल दीज थिंग्स, and then in the future means when the program is getting executed, all these identifiers will be required. So we need to know what is the type of the identifier at the time when the program is getting executed. So वहाँ हमें बहुत quick reference चाहिए होगा इन identifiers का, इन keywords का, उन constant values का जिनका आपने यहाँ पे use किया है. So we need a quick reference of all these things. That's why we need a very fast table. So the fast lookup table is known as the symbol table. So symbol table is also an example of the hash table. So, hashing is a technique wherein we require a very quick reference of our data item. Let us look at the direct address table. डायरेक्ट एड्रेस टेबल एक ऐसी टेबल है जहां पे आप किसी की के कॉरस्पॉन्डिंग एक लोकेशन में जाते हैं और वहां से किसी डाटा आइटम को क्विकली या तुरंत एक्सेस कर लेते हैं. फॉर एग्जांपल, अगर मेरी की 11 है तो मैं किसी एरे को रेफर कर रहा हूं जहां पे 11 इंडेक्स पे इससे रिलेटेड डाटा आइटम प्रेजेंट है. हो सकता है आप इसको ऐसे मान सकते हैं, लेट्स से देयर इज अ रोल नंबर, there is a roll number, let's say 12074. So 12074 is a roll number which is a key value. In case we want many information related to a student who has a roll number 12074, then in the direct address table the data item related to 12074 will be stored at some location or some index 12074 itself. तो आपको केवल इस एरे में या इस टेबल में 12074 इंडेक्स पे जाना है और वहां से आप सारी इंफॉर्मेशन को फेच कर लेंगे. सो इट मीन्स इट्स अ डायरेक्ट, इट इज रेफरिंग डायरेक्टली टू द लोकेशन वेयर योर डाटा आइटम्स आर स्टोर्ड. सो ये मोटिवेशन हमारे लिए क्रिएट करता है डायरेक्ट एड्रेस टेबल, जिससे कि हम डाटा आइटम्स को सर्च कर पाएंगे. नाउ एक और एग्जांपल लेते हैं जिससे कि डायरेक्ट एड्रेस टेबल के बारे में हमारी ज़्यादा अंडरस्टैंडिंग हो. फॉर एग्जांपल, लेट्स से वी हैव सम नंबर्स गिवन 4, 3, 1, 2, 5 and so on so forth. All these numbers are in the range of 0 to 10, and we have to find out which of the numbers are repeated in this set and which of the numbers are not repeated. So let's take a table and let's say this is the direct address table. The indexes of these tables are 0, 1, 2, 3, 4 and so on so forth up to 10. In case I have a number 4, I will go to the 4th index in this table and will update the counting to 1, saying that the number 4 has appeared once. We have initialized all the elements in the direct address table as 1, as 0, and then every time a number is occurring or every time we are seeing a number, we are going to that index and updating the count from the existing count. For example, we are referring to this entry 3, going to the index number 3. There is a number 0 and we have updated that number to 1. Similarly, we have a number 1, we go to the 1 number index, the earlier number there was 0, we are updating that counter by 1. We have a number 2, we go to the 2 index directly, this is a direct address table and we update the counter from 0 to 1. We have a number 5, go to the index number 5, update this counter to 1. We have a 7, go to the 7 and update this counter to 1. We have 1, go to this 1 index and update this counter to 2. We have 0, go to the 0 index and update this counter to 1. We have 3, go to the 3 index, the earlier quantity here was 1, update it to 2. Number is 2, go to 2 index, update this counter to 2. A number is 4, go to the 4th index, update this counter to 2. We have a number 1, go to index number 1 and update this counter to 3. We have a number 8, go to 8th index and update this counter to 1. We have a number 10, go to the 10th index and update this counter to 1. Now the final quantities here are 1, 3, 2, 2, 2, 1, 0, 1, 1, 0 and 1. Let's mark the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. In the given table you can see that there are certain entry which are 1 and there are certain entries which are 0. So 0 and 1 are our desired entries. We had to find out what are the numbers which are not repeated. So you just traverse this table and you will be able to find out which of the numbers are not repeated. For example, if I traverse the table, we go to the 0 index, the quantity here is 1, we can say that the number 1 has not got repeated. So we will number 0 has not got repeated. So print this number 0. Similarly, this entry, this is 3, the number is repeated, 2 number is repeated, 2 number is repeated, 2 number is repeated, 1. So 5 is the number which has not got repeated. Similarly, 6 is the number which has not got repeated because the value here is 0. So 7 is also not repeated, 8 is also not repeated, 9 is also not repeated, 10 is also not repeated. So this way, by referring to this direct address table, by making direct changes to the direct address table, you are able to find out which of the numbers are repeated and which of the numbers are not repeated. There is another example of the direct address table, or where you actually utilize the concept of the direct address table, is the counting sort. In case you have to do the counting sort, which is a linear time sorting technique, this can be done through the direct address table. There is another example. Let us say there are two strings given and you have to find out if they are the anagrams. Anagrams means these two strings are the strings wherein the characters are same. So in case you need to find out if those two strings are anagram or not, you can do it with the help of the direct address table. So now this actually creates the motivation behind the, or the background behind the hashing technique. So what we have a key value. In case you apply a hash function on the key value, you will get a location L. Let us say there is a table. Okay, every time working with the direct address table will not be possible for us, because the key may not refer to the location directly. For example, you are taking a roll number. If you are taking a roll number of AKtU, so this goes like this: 12031000127. You can see that this is a 10-digit roll number. Nowadays the roll numbers are coming with the 13 digits. So that's way too long. So we cannot have that much size table, क्योंकि हमें तो डायरेक्टली एक रोल नंबर से किसी लोकेशन पे पहुंचना है. तो रोल नंबर से डायरेक्टली अगर किसी लोकेशन पे पहुंचना होगा तो वी कैन नॉट डू सो, बिकॉज वी हैव सच अ बिग नंबर इन द रोल नंबर. So we apply some technique by which this number can be reduced. So we apply a hash function on the key which reduces the number, and which reduces the number in the size of the table or in the location size of the table. For example, if I have 100 records to be stored in this table, in the hash table, I will say that the indexes may be from 0 to 99. So I can say that the indexes are of 2 digits only. So I will reduce the roll number from 13 digit or 10 digit to 2 digits by some functions. So those functions are known as the hash functions. And once we get that location, we will store our key there. हम अपनी key को वहाँ पे store कर देंगे. So here in this notation we have h, which is referring to the hash function, k, which is referring to the key value, जिस की को हमें स्टोर कराना है या जिस की के बेसिस पे हमें सर्च करना है. Here we should also understand that the storage and the retrieval process are same. The process by which we will be storing our numbers in the hash table, we will be storing our records in the hash table, the same will be the retrieval method. This L refers to the location in the hash table. In case this is the location, this is the hash table, this L may be some of the address in this hash table, or some location or some index in this hash table. Now let us look at some of the functions, some of the hash functions. तो जो कुछ hash function है, they are defined as, let's say, division method, mid square method and folding method. These are the popular hash functions. There are many more, but these are the popular hash function. So what does the division method say? Let's say we have a key value and we have a hash table of size 100. The locations will vary from 0 to 99. It means we have a 2-digit number or 2-digit address. So we need to find out a 2-digit address with the help of this key value, with the help of a hash function. So the hash function may be like, we have to take its modulus with the 100. This quantity will be any number in between 0 to 99, and that will actually be the address of the key in the hash table. The mid square method says that you take the square of the key, and then from the square of the key you select the key value or the data item which lies in the between. For example, if I have a 6-digit number, after squaring the key, then the data item that is lying in the mid is 34. So you pick this will be the address of the item, data item in the hash table, or location of the data item in the hash table. The folding method suggests that let us say you have a key like this 1 2 3 4 5 6 and you have to find out the address of 2 digits. So, you divide this number in the group of 2, then you sum all these 2, you sum 1 2 plus 3 4 plus 5 6, whatever number it comes out to, let us say the number comes out to xyz, you discard the carry and yz will be the location of the key in the hash table. So, by any of these methods, obviously you will have to apply any of these methods, not all the methods, not mixture of all these methods, you will have to apply any of these methods to store your numbers in the hash table, and while the retrieval you will be using the same method. Okay. Now, let us have a look at the division method in detail. Let us say I have some key 1 2 3 4 5. So, this is the key which is given to you and you have to find out the address of this key in the hash table, location of this key in the hash table. For finding out the address, the simplest method could be to divide this with 100 in case the address is of 2 digit. Here you can see that there is a hash table and in this hash table the locations are 0 1 2 3 and so on so forth up to 99. So, the largest index here will be of 2 digits. So, we will be finding out a 2 digit number. Okay. So, the simplest method could be to take its modulus with 100 and this value comes out to 45. So, 45 may be the location of this key value in this hash table. But now suppose you have a number like this 2 3 3 4 5, this is the key. In case you take the modulus of this number with 100, this will again come out to 45. If you have a key like 7 6 3 4 5 and you take a modulus of this number with 100, then this number will be 45. So, you can see that all these keys will map to the same location. So, that actually is a collision, because many of the key values are having the same hash address. This actually is not possible. We cannot store all these keys at the same location. So, to resolve this method, what we can do, we can apply some criteria by which the repeated remainders could be least possible. So, for that what we are going to do, we are going to divide this key with a prime number. Let us divide it with a prime number. For example, if I have the locations from 0 to 99, you find out the nearest prime number to 99, or you just find out the nearest prime number to 100, but on the lower side, not on the higher side. So, nearest prime number is 97. If you take its modulus of key with this 97, then the locations that you will get will be from 0 to 96. So, location that you will get will be from 0 to 96. Yes, there will be some wastage, the location number 97, 98 and 99 will actually get wasted. We can actually compromise with this much wastage, okay, but we cannot compromise with the collisions. So, this is actually a good method by which you can find out the location of a number. Now, let us write few lines as the algorithm for finding out this. So, let us say there is a table T and which has a size n. Let us take a key k for which we have to find out the location. So, you find out the nearest prime of this k. Let us say there is a function nearest prime that will find out the nearest prime to n, not k but n. N is the table size. Let us say the nearest prime is p. You take the modulus of this number with this p, let us say this is the remainder, and this remainder actually is the location. So, you can return this r, that will be the address of this key in the hash table. Okay. So, there is another function which is mid square method. I already have told you that mid square method is in which you square the key. Let us say the key value is 6326. So, you take its square. Once you take its square, the value comes out to 400,18276. This is actually 8 digit number. If the table size is 100, you are expecting that we will be getting a 2 digit address. For extracting a 2 digit number from this number which you have obtained after squaring the given key, you delete 3 digits from the right, you delete 3 digits from the left, and the 2 digit that is there in between is actually the address. So 18 will be the address of this key in the hash table. Similarly, if you have a 1328, you are getting a 7-digit number. So for in this number you discard 3 digits from the right. After this, 2 numbers or 2-digit number will be the address. So what you are actually targeting, you are targeting that the number which has been given, let's take the square of the key. Let's say square of the key is denoted as S. Then you take or you divide this number with 1000. This will actually discard last 3 digits. So whatever remains, let's say this is S equals to S divided by 100. Whatever remains, you take its modulus with 100. This actually will be the location of the given key in the hash table. Return this remainder R. Now there is a folding method. What does the folding method say? If you have to find out a 2-digit address, for finding so, let's say this is the key given, you pair the numbers, you group the numbers in a group of 2 from the right hand side to the left hand side. Okay, so अगर आपके पास नंबर 1 2 3 4 5 6 7 8 9 1 2 गिवन है तो इसमें दो दो का ग्रुप आप बनाएं और उसके बाद फिर इन ग्रुप्स को आप सम कर लें. लास्ट में एक डिजिट बचता है, उसको ऐसे ही रहने दें, कोई बात नहीं, हम इन सबको सम करते हैं. इट मीन्स आई विल सम 1 प्लस 2 3 प्लस 4 5 प्लस 6 7 प्लस 8 9 प्लस 1 2 and this number is 237. So since we have to find out a 2-digit address only, so you discard the carry 2 and 37 will be the location of this item in the hash table. I leave algorithm on you to write. This will be a very simple algorithm. You will just be dividing this number repeatedly with 100. Okay. Now we have done lot of efforts to actually minimize the collisions, लेकिन फिर भी collisions हमारे हैश टेबल में हो सकते हैं. अगर कॉलिजन्स होंगे तो कॉलिजन को रिजॉल्व करने के दो मैकेनिज्म्स हैं. एक मेथड है ओपन एड्रेसिंग मेथड और एक मेथड है सेपरेट चेनिंग मैकेनिज्म. ओपन एड्रेसिंग मैकेनिज्म में हम ऐसा मानते हैं कि पूरी टेबल हमारी है. अगर किसी ith लोकेशन पे कॉलिजन हुआ है तो आप i+1 लोकेशन देख लीजिए, i+2 लोकेशन देख लीजिए, अगर वो फ्री है तो वहां पे जाके डाटा आइटम स्टोर कर दीजिए. सो पूरी टेबल हमारी है. द एंटायर टेबल इज माइन. आई विल कंसीडर दैट. ओके, so it is very easy to implement. This is the advantage. But what is happening that it is occupying the space of the other locations or other key items. It is encroaching in the areas of the key values which may come in those areas. Okay, so that is the disadvantage. Separate chaining mechanism क्या है कि इसमें कोई भी एक डाटा आइटम किसी डिफाइंड सेल में ही आएगा. हम सेपरेट चेन्स बना देंगे वहां पे और वो किसी अदर मेंबर के एरिया को इंक्रोच नहीं करेगा. सो दिस इज द एडवांटेज. बट द डिसएडवांटेज विल बी दैट इट विल रिक्वायर डबल द मेमोरी साइज ऑफ दैट व्हाट इज रिक्वायर्ड इन द एरे मेथड या फिर ओपन एड्रेसिंग मैकेनिज्म अगर हम यूज करेंगे तो हाफ ही केवल स्पेस यूज होगा, जबकि सेपरेट चेनिंग में उसका डबल मेमोरी यूज होगा. ना आइए ओपन एड्रेसिंग के बारे में और देखते हैं. तो ओपन एड्रेसिंग मैकेनिज्म्स आर ऑफ 3 टाइप्स: लीनियर प्रोबिंग, क्वाड्रेटिक प्रोबिंग and double hashing or rehashing. What happens in the linear probing, that let's say the h location is the location of the data item that you found with any of the hash function. In case that is busy, you will look at the hash h+1 location if that is free. Okay, then you will look at the h+2 location if that is free. Whatever location is free, you will store your data item there. Okay, so in the linear probing you are going linearly ahead until a blank space occurs, and the same will be the retrieval method also. This is for the storage and same will be the retrieval method also. जहाँ पे भी मुझे blank space मिल जाएगा या फिर जहाँ पे भी मुझे की मिल जाएगी blank location पे, वहाँ पे हम अपने सर्च प्रोसेस को स्टॉप कर देंगे. लेकिन अगर सर्च दो पॉसिबिलिटी है, या तो आपको आपका डाटा आइटम सर्च करके मिलेगा या नहीं मिलेगा. तो अगर आपको की सर्च करके मिल जाता है तो इसका मतलब कि सर्च सक्सेसफुल हुआ, और अगर आपको ब्लैंक स्पेस मिलेगा तो इसका मतलब है कि आपका सर्च अनसक्सेसफुल हुआ. क्वाड्रेटिक प्रोबिंग में अगर h लोकेशन बिजी है, सो देन यू लुक फॉर द h+1 स्क्वायर लोकेशन. इफ दैट इज आल्सो बिजी, यू लुक फॉर द h+2 स्क्वायर लोकेशन एंड सो ऑन सो फोर्थ. So in the quadratic probing, you look for these location h. If that is busy, look for h+1 square. If that is busy, look for h+2 square. until a blank space is occurring for the storage process. Wherever the blank space occurs, you store a data item there. But in the retrieval process, you look for these locations only, h, then h plus 1 square, then h plus 2 square, and the moment you find that your element is there, your search key is there, you stop your operation there, or your search is successful. But if the blank space occurs, it means that your search key will never be found. Okay, your search key will not be found. So that is the retrieval method. डबल हैशिंग मेथड सेज कि अगर आपने h कैलकुलेट कर लिया है तो आप एक h डैश भी किसी मेथड से कैलकुलेट कर लीजिए. अगर h लोकेशन बिजी है तो आप h प्लस h डैश लोकेशन को चेक कीजिए कि क्या वो फ्री है. अगर ये फ्री नहीं है तो आप h प्लस 2h डैश लोकेशन को देख लीजिए कि क्या वो फ्री है. अगर ये भी लोकेशन फ्री नहीं है तो आप h प्लस 3h डैश लोकेशन को देख लीजिए, एंड सो ऑन सो फोर्थ. तो यही प्रोसेस रिट्रीवल का भी होगा, यही प्रोसेस स्टोरेज का भी होगा. So these are the three methods in the open addressing: linear probing, quadratic probing, and rehashing or double hashing. Now let's take a question by which you will be able to understand how the linear probing goes. So A has a hash address 7, store A at 7. B has a hash location 4, store B here. C has 0 location, store C here. D has 1 location, store D here. E has 11 location, store E here. F has 4 location, but 4 location is busy. So you store at 5 in case you are doing the linear probing. 5 is free, so you can store it there. So 11 is busy. You look for 11 plus 1, but that is 12. So you will take its modulus with the size. Okay, you take its modulus with the size, and size is 12. So 12 modulus 12 is 0, but the 0 location is also busy. Then you find 11 plus 2 modulus 12. This value will give you the location number 1, but 1 is also busy. So you find out 11 plus 3 modulus 12. This is telling you 2 location. So you store your data item at 2 location because 2 is free. So G can be stored at 2 location. H has a location 7, but 7 location is busy. So you find out 7 plus 1 and mod size, that means 7 plus 1 8 mod 12. So this will give you a location number 7, and you can store your data item here. Then you have I, which has a 10 index, so you can store your data item I here. So this way the linear probing goes. In the linear probing, in case a location is free, you just see the next location. In case that is also free, you see the next location. So this is the table that we have actually found after the storage. You can search also with a similar mechanism. Now what is the average number of probes we required for the successful search? Let us say we are searching for this 7, we are searching for this A which has a location 7. So A will be found at 7 location only, so you require 1 comparison. B, location number 4, B can be found at location number 4, so in 1 comparison only you can find this B. C has a 0 location, C can be found at 0 location, so 1 comparison. D has a 1 location, D can be found at 1 location. E has 11 location, E can be found at the 11 location in 1 comparison only. F has location number 4, but 4 location is busy, so you will look for 5th location. 5th location you find F, so 2 comparisons are required to search this F data item. Then G, G is not found at 11, G is not found at 0, G is not found at 1, but G is found at 2 locations, so 4 comparisons are required to search this item. Then you have a H which has a location 7, location number 7 is busy, you will look for the 8th location, so you require 2 comparisons for this. I has a location number 10, this location number 10 is free, and you have, so not free, but you have found actually I here, so you require 1 comparison here. So you just sum all these and divide it with the number of keys. So 1, 2, 3, 4, 5, 6, 7, 8, 9 are the keys. So you divide it with 9, that will be the average number of probes required for successful search. Okay. Similarly, you can find out the average number of probes for unsuccessful search. You search for the blank location. Wherever you find a blank location, you stop your search there. So you are actually finding out the unsuccessful searches. Now in the quadratic probing, what you can do? Let us say there are some collisions occurring. So you will, if there is a collision occurring at some location, you search for the location h plus 1 square and then mod 12. In case this is busy, you search for h plus 2 square mod 12 and so on so forth. So, by this we have this arrangement with the help of the quadratic probing. What happens in the separate chaining? If A has a location 7, store A here. In case B has 4 location, store B here. In case C has 0 location, store C here. In case D has 1 location, store D here. E has 11 location, store E here. F has 4 location, at 4 location we already have B, so apply or insert after B. G has 11 location, store it here after E. Then H has 7 location, store it after this. I at 10 location, store it here. So, no item has disturbed the area of the other. So, we have stored the items like this. So, this method is the separate chaining mechanism. Okay. Now, this is the summary. In every of the hash search, you are expecting that it has to be in the constant time. So, theta 1 time will be required for the searching in the average case, whereas in the sequential or the binary search it requires theta n and theta log n time respectively. So, we have actually saved lot of time in the hash search mechanism. Thank you.